Let me ask you something. If I ask an LLM a hard question and it gives the right answer, did it actually reason or was it just a luck? Because the strange part is the same model can sometimes solve very complex problems but fails miserably at counting number of R's in the word strawberry. And most people in AI favor one of these two arguments. Either they can reason just like humans or they are just next word predictors. And honestly, both of these miss a point because the answer lies somewhere in between, which is way more interesting and subtle. So let's get one thing out of the way. Yes, large language models can reason to a certain extent, and we have a strong empirical evidence for that. But the catch is the reasoning is fragile, and a lot of times it's hidden within the model, which means it can work incredibly well in some situations and fail miserably in other situations. So in this video, we are going to cover all these different aspects of reasoning and understand how we can mitigate them. Before we dive deep, let's even understand what exactly does reasoning even mean. So reasoning is a process to think logically about a problem where the solution isn't very obvious. And the important part is, it's not about getting to the right answer, it's about how you got there. Remember in school when the teacher asked you to show the work, they weren't very interested in your final answer. They wanted to check your thinking process. And when we think of how we as humans perform reasoning, there are several components for that. One is memory. We use both short-term as well as long-term memory to recall facts and information. We gather evidence from the outside world by performing some experiments, looking at the observation, or maybe search if it's required. We also try to form some hypothesis if the information is incomplete by asking the question, hey, what is the most plausible explanation for this? Next, we also do self-reflection by reflecting on our own thinking and try to correct ourselves. Another one is the thinking process itself. Our thinking is very abstractive and sort of present in our thoughts, unlike LLMs that do the reasoning in the form of text. And on top of all of this, we also do causal reasoning where we try to understand the cause and effect. Let's try to understand this by a very simple example. Let's say you ask a question, why do we have seasons on Earth? Someone from a vague memory can say because Earth is closer to Sun in summers, but this is just a confident answer and it's wrong. The real explanation needs to pull multiple things together. You would need to refer diagrams or understand Earth's axial tilt and do causal reasoning about how sunlight hits the surface. So you understand this is how you construct a solution through the reasoning. Okay, so now let's talk about large language models. At the core, they are trained on an objective to predict the next token. And they are trained on massive amount of textual data. And as you scale the models with more data and compute, something surprising happens. New abilities start to emerge, and reasoning is one of those abilities. In 2022, researchers tried a very simple thing. They just added one sentence to the prompt after the end, which is, let's think step by step. That's it. And the results were impressive. On multi-ariths, the performance went from 17.7 to 78.7, and the similar performance was observed on GSM 8K. And this was exactly the time where people coined this term prompt engineering and used to call this process very unscientific. But I can show you with one example which can give you a different perspective. Consider this question. I have 3 apples, my dad has 2 more than me. How many apples do we have in total? And I gave this question to the Quen model and the answer it returned was 5. And you could see from the probability distribution, all the top 3 tokens are somewhat talking about 5 and the correct answer is 8, whose probability is almost 0. Now when I just added this phrase, let's think step by step, and suddenly we see something very interesting. Now the model gives you the right answer and look at the probability of 8. It's almost 1. Okay, so what we are essentially saying here is by generating the intermediate reasoning tokens, the model has sort of reshaped its own future predictions, pushing the probability of the right answer high. But we have a problem. Even when the model reasons step by step, there is no guarantee that we are on the right path. And each explanation is just one trajectory out of many, and some paths leads to the correct solution while others sounds plausible but they are wrong. So the question arises, how do we get the right one? One group of researchers argued that we have put a lot of compute on training, but haven't done anything on the inference side. So what if we try to scale the inference? So instead of one trajectory, we try to sample many reasoning paths and select the best one. And as a result, what researchers observed that with DeepSeek Coder V2 Instruct, the accuracy jumps from 15.9% one sample to 56% when you sample 250. which beats the previous single sample state of the art, which was around 43%. So the takeaway is, it's not about thinking harder, it's about thinking multiple times. But in real world applications, sampling hundreds of reasoning paths is very impractical. It's very slow, it's very expensive. And one of the ways to fix this is by collecting the reasoning traces and perform supervised fine-tuning on it. But one issue with SFT is collecting these high quality reasoning traces is very laborious and very costly. And also human biases comes into picture when they annotate it. So this is where reinforcement learning with verifiable reward comes into picture. So instead of supervising the model how to reason, we actually incentivize it by providing the high reward when the final answer is correct. Now for tasks where we have deterministic verifiers such as maths, logic or coding, we can design the accuracy reward which will help the model to discover the reasoning by itself. And this is exactly what DeepSeek R1 paper showed. During the training they had their aha moment when on one math problem, the model starts with an incorrect line of reasoning and midway it self-corrected itself. Not because it was told how, but because we rewarded the correct answer, the model was somehow able to come up to the right reasoning in order to get the higher rewards from the right answer, which showed the reasoning behavior emergence. Another point of discussion is, how does LLM think, or what is the process? Because most people believe that they think in text, unlike humans. But researchers from Google and UCL found evidence for latent multi-hop reasoning inside model representations, where in some relation types, the same hidden pathway appeared in over 80% of the prompts. So far, what we have learned is that yes, LLMs can reason as long as the information required to perform reasoning is present either in the context window or the model weights. But what if it isn't? For example, a key fact is missing, or a calculation requires extreme precision, or you need some external verification. And this is where standalone LLMs fail. This is like comparing LLMs with the human brains. So human brains without the body is not sufficient to perform the reasoning, because we need to take actions, do some experiments, and from those observations we will deduct something. So similarly, what we are missing here is the system around the LLM. And this is where agentic reasoning comes into picture. Today, when we create agentic systems or agents, we give model tools to act, like call API, schedule meeting, but we rarely provide tools for reasoning, which is very important thing which we are missing. For example, if we could provide tools like web search for the reasoning, which can fill the missing information, or write code and execute it for the precise computation. Because once we do it, it changes a lot of things. Let me explain this with a simple example. I asked this question to model, is UK to my left or my right? And the response was, I can't determine because I don't have the access to your location. In another experiment, when I provided the location tool to the reasoning, this is what it provided. So it started with some reasoning and then quickly realized that it does not have the access to my current location, and then it called the location tool to get my current location and then continued the reasoning. And you could see from the final answer that the answer was, it's left because UK is to the left from India. Same model, and you could see the better experience for the end user. Another important point when building LLM based system is the reasoning instruction itself. Most of the time we only focus on the task instruction, like what the task is, what should the output look like, or what are the constraints. But people rarely focus on how the model should perform reasoning. It started with the chain of thoughts, but several papers after that, like self-consistency, plan and solve, or tree of thoughts, has shown that using the right reasoning prompts or instructions can lead to huge improvements in the performance without changing anything in the system. Alright, so the question of the video, did LLMs really learn to reason? In my opinion, we are asking the wrong question. And the better question is, under what conditions does reasoning succeed or fail? And what we have covered in this video is 1. LLMs have demonstrated the capability to reason as long as the information is available. 2. Prompting matters for reasoning too. 3. More compute during test time helps, but it does not guarantee correctness. And 4, the reasoning can break when the system around it is missing, such as not providing the appropriate tools for reasoning as well. And a lot of questions raised in this video still remain open. And of course, we haven't reached nowhere close to human reasoning. But interestingly, this is where the research is heading towards. All the papers and data sources are linked below. If this changed how you think about AI reasoning, please let me know in the comments. And please like and subscribe for more such deep dives. Thanks for watching.